Hi there, this is Ajit. Welcome to Step by Step Data Science tutorial. So today we are in part 6, multi-class classification using logistic regression. So today we will discuss one versus all concept and implement multi-class classification from scratch in Python. And also we will discuss about OneHotEncoding. So let's start. In last video, we discussed about binary classification where the output is either 0 or 1. So our output is of two classes. So our y is 2. In multi-class classification, the output is more than two classes. So our y, the output variable, is greater than or equals to 3. In the picture, binary classification have two classes and it's being distinguished by a decision boundary. Whereas in multi-class classification, we have more than two classes. Here y is equals to 3 and is being distinguished by three classes. So one versus all concept is we have three classes over here. One is green, second is blue, and third is red. What we do is we generate three binary classification, one for red and blue, and one for green. Blue and red is one. Again, one for blue, green, and red is for another, and finally for red, green and blue is a one mixture. So what we do is we draw a decision boundary over here. So this is my green class and this is my combination of blue plus red. Likewise, we draw another decision boundary here. So this is my combination of green plus red and this is my blue class. Again, we draw another decision boundary over here and this is my red and this is again the combination of green plus blue. Let's say, so hypothesis for this will be, for my first class will be h1 of theta of x. Likewise for this it will be h second class of x theta of x. Likewise for this it will be h3 theta of x. So my final hypothesis will be, h of I of theta with respect to x will be probability of y equals I given x parameterized by theta, where my I is 1, 2, 3. This is my number of classes. And finally we take s theta of x of I is my max of s theta of x. So whichever have the maximum hypothesis, maximum value, we take that. So this is what one versus all concept is. So we distinguish, if we have three classes, we distinguish into three binary classification, and for green we merge the remaining classes into one and do a decision boundary, and finally we take max of whichever have the highest hypothesis. So we will be implementing this in our Jupyter notebook. So this is my library. So this is the dataset that I have used from Coursera and Learn course. So this is my x and y. So this is my xc. So here let's explore our data. So this is a handwritten image and its size is 5000 by 400. So shape is 5000 by 400. So this is my row and this is my 20 by 20 pixel image. So let's say my image is, suppose handwritten image 1. This is my 20 by 20, which is 400. So this is my 420 by 20 pixel image, and which is of, so total we have 5000 image, and each image size is 20 by 20 pixel. So let's do a plot and check one image how it looks like. So how can we check is plt dot I am so x of suppose say 0, 20 by 20. So here we can see, so this is my image. So if we look at my output y of 0, so this is 10. So what value we have in y is 1 to 10. So this 10 is our 0 and 1 is 1 and 2 so on. So this 10 refers to 0. So let's check 800 and y of 800 x of 800. So this is my 1 and y of 800 is 1. So this is my image, x is my image and y is my output. So this is our multi-class classification because our output variable is more than 3. If we check here y 1 to 10, 0 is our 10 and remaining 0 to 9 digit. Now let's take a sample of random sample of 100 images and visualize our data. So how can we take a random sample is let's say my n is equals to 100 and my index is equals to np dot random dot choice and x dot shape 0 comma so and my replace will be false. Why replace is false? Because at every time we will get new output. That's why we have set replace as false. Let's say this is data equals x of index comma. So we have generated 100 random image. So this is my 100. I have generated a random 100 image and it will change every time. Now let's do a visualization of my 100 random images. So what I will be doing now is, so my random, so my x dot shape now is 100 by 400. So we know that we need to, for plotting an image, we need to reshape it that to 20 by 20. So this needs to be 20 by 20. So this I will do a, so my width will be, I will do square root of 400 my width, and my height will be, which will be again be 20, and my height will be, so total number of feature is 400. So I will do 400 divide by width. So this would be my formula to take square root, and this would be the formula to take, so if this is my m and this is my n, then my width will be square root of n and my height will be n divided by width, which will again be 20 by 20. So I am using this formula to generate my 20 by 20 image. Likewise, I will display row by taking, this is my m, so I will be taking the square root of m, which will be my 10, and likewise I will display the column will be again by m divided by root of m, which will be again by 100 by 10, which is 10. So this is the basic formula that I will be using to show 100 images. Okay, So let me write the code from scratch. So let's say my class is OneVsAll, and I will be using multiple inheritance, and will be using both classes of one is for regularization and one is of logistic regression. The reason for using both classes is we need to pull all functions like hypothesis from logistic regression module, sigmoid and all, and from regularization we will be using cost function and all. So I am pulling both classes in my OneVsAll class. So this will be my default int. So my display data will be x comma, let's example width is equals to so m comma n will be my shape, and my width will be, like I said, width will be let's say integer of np dot round, just to do a round off so that we have a whole number. So I say like we will be doing square of n. So again my height will be n divided by width. In my display row will be integer dot floor dot sqrt of m, and my display volumes will be m divided by display row. Let's say my figure arg is plt dot subplots, number of rows is my display rows, and number of columns is my display column, and my figure size is 10 by 10. Okay, so what I did is, so my row display row is 10 because of this formula. This is the square root of m, which is 10, and display column is again 10, which is m divided by square root of m, which is 10, and my width is 20 as per this formula, and height is again 20. So display row and display column, what it does is it creates a frame where we can have 10 picture in a sequence, and this would be the size of my image. So we have 10 boxes like this, it will be 10 by 10, so that we can and it will contain handwritten images like 1 2 3 4 5. So 10 by 10 box, and this will be my image size. That's what I did right now. Subplot will create a 10 by 10 box images for I comma x in. We need to flat this array so that we can do a plot. m.i.show. This is what I this will be my in my iteration, because I will be visualizing all 100 images. Dot reset sample with comma right order equals f, and then my cmap will be the gray image. So this is a gray images, and let's turn off my axis. Okay. This is working fine. Let's restart my kernel, and let's create an object of my class OneVsAll equals. This is my class OneVsAll. Let's call this method. So here is my 100 images. So 10 by 10 size. So 1 2 3 4 5 6 7 8 9 10. 10 by 10 matrix we have created, and this is the visualization of our data. So we can see all hand digit number from 0 to 9, and 10 is 0 in our case. So now let's append one. Let's write a function that append one in our data. Append one self comma x m comma n cos x dot c. X naught will be again np dot ones of m comma 1 is equal to dot append x naught comma x is equals to 1. Return x. So now x will be negative x. Now let's initiate our theta. Dot zeros dot c comma 1. Save of x. So my initial data is 1 by 1. This looks good. Now let's calculate minimum cost. This will be the number of labels and number of coefficient and dot n. So if you might be wondering what is minimum cost and all. If you have any confusion on that, then please watch my all previous videos. I have explained that in my previous video. Let's create a so what I am doing is, so here our output variable y is 1 2 3 4 5 6 7 8 9 and 10, and this 10 is from 0. So we have our handwritten data from 0 to 9. So in machine learning model, so our output for handwritten digit, because this is an image, so it should be either 0 or 1, 0 or 1. So how can we do this is by appending all zeros. Suppose for example, for what we can do is we have 10 classifiers, so it will beat out 10 zeros and 1. This denotes for 10. Likewise for 1, we can do 1 here, and all remaining will be 0, and so on. For 2, it will be 2 will be 1, all will be 0. So this is what we call one hot encoding. This is one hot encoding where we populate all zeros except for those that we need to find output for. Here we need to find we have output 10, so this is 1. Here we have output 1, so our one hot encoding will be 1 and all remaining will be 0. For 2, this position will be 1 and all will be 0. So now what we are doing is we are calculating minimum cost. This is the minimum error in our module, and we will equate y equals c. What this does is let's say if my a is 1 2 3 and my b is only 3. So if we do a equals b, this is false. So it will be true if I in b. Suppose if we do a loop and say if I equals b, and let's print it out as. So this is what is our output, either in 0 or 1. So this is what we will be doing. And so our output will be here, will be, so this it will be our label. So suppose for example for 3, and our handwritten digit is from 1 to 3, 4, 5, 6, 6, 7, 8, 8, 9. So we will equate this with our, this is my number of labels. So we will equate this value in our loop so that it will output either 0 or 1. So this is what we will be implementing in while calculating minimum cost. So why we need to do this is because our handwritten digit is from 1 to 9, and we need to convert that into 0 or 1. That's why we equate y equals that label value. We will add that. So this is my label. So right now my label is 10, 0 to 1 to 10. So I will be adding a loop for this label, and my digits will be from I, if I, else 10. So why I did this is to distinguish 0. So 0 is my 10. So my now all theta will be, we will be using Scipy fmin.cc, where f will be my cost function, my x naught will be all theta, theta of I, comma, my f prime will be gradient, my arguments will be x, and here we do y equals this digit. Why we do this is because this will result in binary 0 or 1 output. That's how we compare, and we will flatten this. Let's include our lambda, and let's say my max iteration is 50. Set it to 50. Return all theta. Let's run this. Let's recall this dot. The function name is minimum cost. Also, we need to copy cost function and gradient from regularization. So this is what we already wrote in our last tutorial. So you can view my last tutorial if you have any confusion regarding cost function and gradient. That's it. So this is my cost function. This is my gradient. So I will pass x, y. My number of labels is 10. How did we find this is because my set, if we do set of y, so we have then upside of I. We have 10 labels, so this is my label, and let's give lambda as 0.1. So why we have included lambda? Because we have our output is more than 10, or more than 9. So here we can have an overfitting issue. That's why we have included. We have so many features, so we have included lambda. Let's say all theta. So here we get our optimal value of theta. Now what we need to do is, so now we have generated our h theta. So h1 of h h1 of theta of x, h2 second class for theta of x. So we have generated all these. So now what we need to take is to take maximum of h theta of x. So my y predicted will be np dot argmax. This is how we take maximum value. So this is my object dot sigmoid x and my all theta. This is my optimal value of theta that I have. Need to do transpose, comma axis equals 1. So I have called sigmoid function here. So sigmoid function is not in this class. So sigmoid function is in logistic regression here. So here we have used two classes within our main classes. So this is a multi and let's say my y is y if y else in. So we can distinguish for y in y, so that we can distinguish our zero cases. Now let's calculate the score. So this is again I have pulled from logistic regression. So I have applied multiple inheritance, and that's how I was able to pull those information. So my accuracy is 95.06%. So now let's predict one output. So let's say so for in 800 rows we have 1. Let's see what we have in our output. Predict for 800 is 1. So it's working fine. For let's say for 0, check for 0. So for 0 is 10. So our 0 is right now 10. So now let's verify this with a machine learning logistic module. So if we run the model taking our regularization 0.1, we get 93.36% accuracy, and ours is 95. So we are in upper side. So OneHotEncoding, let's implement OneHotEncoding now. This is from scratch. So right, so I said like whatever variable we have over here will be converted into 0 and 1. So what would be the logic for one hot encoding? So one hot encoding logic would be, suppose if my y is 1 2 3 up to 10. So this is my number of labels. So we know that, so if this index matches with my original data, so this is my number of labels. So this is my labels, and my original y is again 0 0 0 1 1 2 and so on. So if this matches with this, then we populate it as 1. So if my y of I matches with my number of labels, then we populate all these values to 1. So my code will be something like, if one hot coding, say y comma number of labels, let's say Scipy. So right now I'm creating a zeros matrix for that holds both my y and number of labels, and I will be using a for loop that ranges till y of shape of 0, and another loop to check the labels. So I will be using from 1 to number of labels plus 1, because my labels start from 1, and so this range will not include is exclusive of this term, so I have included plus 1. And if my y of I is equals to j, this is the number of labels, and then y of I j minus 1, because we are starting from 1 and our index should be from 0, that's why we did minus 1, which will be equals to 1. So if we have a match between our input and label, we populate 1, else by default 0 is already being created. Let's return. So now my function is created, one hot encoding function. Now let's check whether it's working or not. So y1 hot equals give a class. So my object is this. So my y is my input, and my number of labels right now is 10. So now let's say if my y is 0. So my y 0 is 10. After applying one hot encoding, my y0 becomes all zeros, and 1 is being populated, because as we said, so my output is again my y is from 1 2 3 4 5 6 up to 10, So after applying OneHotEncoding, my output will be all 0, 0, 0, except for this 10 will be replaced by 1. Likewise, let's check for the 800, suppose. And let's check for 800. So this is 1. Hope this makes sense. So that's it for today's session. We have covered OneHotEncoding. We have applied multi-class classification. If you like my video, please subscribe my channel and encourage me to create more videos. Thank you so much.